In the previous class, we have discussed some questions. We have discussed some questions in this exercise 9.4. I hope you have understood the questions well. Haven't you, my dear children? Yes. Now, I'm going to discuss the remaining sums in this exercise. Okay, my dear children? Please watch this video carefully, my dear children. I am presenting PPT. All of you watch this screen carefully, my dear children. See the screen. Pay attention here. 11th sequence and series exercise 9.4. Question numbers 6 to 10. We are going to discuss these questions today in this exercise. Okay, my dear children. Right. Come to the question number 6. Find the sum to n terms of the series 3 into 8 plus 6 into 11 plus 9 into 14 plus and so on. This is the given series. We have to find sum to n terms of this given series. We follow the same steps. Series may vary from question to question, but ultimately we follow the same step, same procedure. Okay, my children. Now come to the solution. What is the given series here? The given series is 3 into 8 plus 6 into 11 plus 9 into 14 plus and so on. If you observe this series carefully, each term is written as product of two factors. This is the first term, 3 into 8. See the second term, 6 into 11. Observe the third term, 9 into 14. So in this way, every term of this series is written as product of two factors. Yes or no? So in this series, first of all, we have to find nth term. What is the nth term of this series? What is the nth term of this given series? By using our previous knowledge, we have to find the nth term of the given series. So first let us take the first factors. See that sequence of the first factors of each term of the given series. Observe the first factors in each term of the series. See here first term, first factor 3. In the second term, first factor is 6. In the third term, first factor is 9. So we have taken 3, 6, 9 and so on. Now, if you observe this sequence of numbers, this sequence form an arithmetic progression. Which is an arithmetic progression? If it is an arithmetic progression, we can find nth term of an arithmetic progression if we know first term and common difference of the arithmetic progression. Yes or no? So here, what is the first term? The first term of the arithmetic progression, that is equal to A, is equal to, what is the first term here? 3. And the common difference of the arithmetic progression, that is small letter d, that is equal to, how do you find common difference of an arithmetic progression? Second term minus first term, or third term minus second term. So what will you get here? Difference, common difference of this arithmetic progression? 3. Here we found first term and common difference of the arithmetic progression. Now we are going to find nth term. Therefore, nth term of the arithmetic progression is equal to a plus n minus 1 into d. You know this formula. You have already learned in your 10th class. You have to remember this formula well. This is very, very important formula for this chapter. That is equal to, in this formula we substitute a value and d value. So a is equal to 3 plus n minus 1 into 3. By simplifying this expression, after simplification we get finally 3n. Okay, we have to simplify this expression. In rough work, do that part, and finally you get 3n. Okay, my children, this is the nth term of the arithmetic progression. Therefore, first factor of the nth term of the given series is 3n. We have found the first factor of nth term. In the nth term of the given series also, product of two factors. So we have found first factor of the nth term of the given series. Similarly, we find the nth term, second factor of the nth term of the given series. Now come to the second part, sequence of the second factors of each term of the given series. What are the second factors in the each term? In the first term, second factor is 8. In the second factor, in the second term, second factor is 11. In the third term, second factor is 14. So we have written the second factors of each term of the given series in this line. See here, see this is step 8, 11, 14 and so on. Now if you observe this sequence of numbers, this sequence of numbers form an arithmetic progression, which is an arithmetic progression. Here the first term of the arithmetic progression is 8. What is the first term of this arithmetic progression? 8. And what is the common difference? Previously I told you, how do you find common difference of an arithmetic progression? Second term minus first term, or third term minus second term. So 8, 11 minus 8, 3, 14 minus 11, 3. So this is the common difference, 3. So we found first term and the common difference of this arithmetic progression. Now let us find nth term of this arithmetic progression. Therefore, nth term of the arithmetic progression is equal to, you know this formula, a plus n minus 1 into d. You have to memorize this formula well. Okay, my children. That is equal to, in this formula, let us substitute the values of a and d. Then we get 8 plus n minus 1 into 3. After simplification of this expression, finally we get 3n plus 5. I'm not showing that the simplification part, my children. That part is left for you in rough work. Take a pen and paper later, not now. Take a pen and paper and simplify this expression. After that, finally you get these two terms only, 3n plus 5. This is a nth term of this arithmetic progression. Therefore, second factor of nth term of the given series is 3n plus 5. So here we found the first factor of nth term of the given series, that is 3n, and this is the second factor of the nth term of the given series. Therefore, the nth term of the given series, that is an, is equal to 3n into 3n plus 5. That is equal to, after multiplying these two expressions, finally 3n 9n square plus 15n. By using the distributive property, we get these two terms. Okay, my children. So we found nth term of the given series, but we have to find sum to n terms of the given series. Means we have to apply sigma notation, summation. Okay, my children. Right. See, therefore, Sn is equal to sigma k is equal to 1 to n ak. For this previous equation, an is equal to 9n square plus 5n. For this equation, we are applying sigma notation on both sides in this step. Okay, my children. That is equal to sigma k is equal to 1 to n 9k square plus 15k. So here These are two terms. For these two terms, we can apply the sigma notation separately. So again, in this first term, 9 is a numerical coefficient. So we wrote this numerical coefficient before the sigma notation. So 9 into sigma k is equal to 1 to n k square. We wrote this first term as 9 into sigma k is equal to 1 to n k square plus. Now come to the second term, 15k is there. In this term also 15 is a numerical coefficient. So we wrote 15 before this sigma notation. So 15 into sigma k is equal to 1 to n k. Okay. So 9 into this notation is nothing but sum of the squares of the first n natural numbers. Sum of the squares of the first n natural numbers. What is the formula? N into n plus 1 into 2n plus 1 by 6. You have to remember this formula, my dear children. You have to learn well. Okay. Plus, come to the second term, 15 into this notation is nothing but sum of the first n natural numbers. In previous class, I explained the sigma k n is equal to k is equal to 1 to n k square and the sigma k is equal to 1 to n k. Okay, you have to memorize these formulae. So n into n plus 1 by 2. This is the sum of the first n natural numbers. We substituted the values. After substituting the values, we have to simplify this expression. We have to make it as a single number. Finally, we have to make it as a single number. See this last step. So here 3 times, 3 2 times. After cancellation, we get in the numerator 3n into n plus 1 into 2n plus 1 by 2 plus here in the numerator 15n into n plus 1 by 2. Now, by taking the common factor from the two terms, what is the common factor? If you observe the factors carefully, here 3 is one factor, n is one factor, n plus 1 is one factor, 2n plus 1 is another factor. Similarly, here 15, n plus 1, 3 different factors are there. By 2 also, one more factor, 1 by 2. So, by observing these two terms, we have to identify the common factor. So here, 3n into n plus 1 by 2 is a common factor. We have taken out, and we wrote the remaining part. So 2n plus 1 plus 5. Okay, that is equal to 3n into n plus 1 by 2 into, after simplification, we get 2n plus 1 plus 5 is equal to 6. So we get here 2n plus 1, 2n plus 6. Again, if you take 2 common from these two terms, 2 gets cancelled. And finally, we get 3n into n plus 1 into n plus 2. This is the sum to n terms of the given series. We follow the same steps for any question. We follow the same steps. Okay, my children. Now come to the next question. Question number 7. Find the sum to n terms of the series 1 square plus 1 square plus 2 square plus 1 square plus 2 square plus 3 square plus and so on. This is a given series. We have to find sum to n terms of this given series. Okay, my children. Right. Come to the solution part. The given series is 1 square plus 1 square plus 2 square plus 1 square plus 2 square plus 3 square plus and so on. If you observe this series, the first term, what is given here? 1 square only. Plus, this is treated as a second term. Okay. In the second term, what is given? 1 square plus 2 square. Plus, treat this entire expression as a third term. What is this expression? 1 square plus 2 square plus 3 square. So, third term is written as 1 square plus 2 square plus 3 square. Not a 3 cube. Here, print mistake. 1 square plus 2 square plus 3 square only. Okay, my children. Right. Now, by using our common sense, nth term of the given series, that is an. What will be the nth term of this given series? 1 square plus 2 square plus 3 square plus 4 square plus 5 square plus and so on n square. In the nth term, nth bracket, let us consider this is the first bracket, this is the second bracket, this is the third bracket, and so on. In the nth bracket, we get this expression. Okay, my children. And if you observe this expression, this is nothing but sum of the squares of the first n natural numbers. So that is equal to, what is the formula? Sum of the squares of the first n natural numbers. Yes, n into n plus 1 into 2n plus 1 by 6. That is equal to, now we multiply these three expressions. Finally, we get 2n cube plus 3n square plus n. After multiplying these three expressions, finally we get these three terms in the numerator by 6. That is equal to, if you split this entire fraction into three fractions, what will you get here? 2n cube by 6. So by simplifying, we get 1 by 3 into n cube plus 3n square by 6. What will you get? 1 by 2 into n square plus 1 by 6 into n. Understood these three terms, my dear children? We have split this entire fraction into three terms. This is nothing but nth term of the given series. Okay, my children? Right. So for this nth term, we apply the sigma notation. Right. Therefore, Sn is equal to sigma k is equal to 1 to n ak. That is equal to sigma k is equal to 1 to n 1 by 3 k cube plus 1 by 3 1 by 2 k square plus 1 by 6 k. We have applied sigma notation for the nth term of the given series. That is equal to, here we use the distributive property. So 1 by 3 into sigma k is equal to 1 to n k cube plus 1 by 2 numerical coefficients. Every time we write the numerical coefficient before the sigma notation. That is why we are writing like this here. 1 by 2 into sigma k is equal to 1 to n k square plus 1 by 6 into sigma k is equal to 1 to n k. That is equal to 1 by 3 into, this notation is nothing but sum of the cubes of the first n natural numbers. This sigma notation denotes sum of the cubes of the first n natural numbers. Then what is the formula? N square into n plus 1 whole square by 2 square. Previously, I gave the formula. At the beginning of this exercise, I gave the formula. You have to memorize that formula well. Okay, my children. Plus 1 by 2 into, this notation is nothing but sum of the squares of the first n natural numbers. This notation we have already used in the previous question also. So n into n plus 1 into 2n plus 1 by 6 plus, come to the third term, 1 by 6 into sigma k is equal to 1 to n k. This notation denotes sum of the first n natural numbers. We have used this result also in the previous question. That is n into n plus 1 by 2. So after writing the values of sigma notations, we have to simplify this expression. Okay. So by observing these three terms, n into n plus 1 by 6 is the common factor. So we have taken out n into n plus 1 by 6. This is the common factor in these three terms. Then within the brackets, we are writing the remaining factors. So n into n plus 1 by 2 plus 2n plus 1 by 2 plus 1 by 2. Now we simplify these three terms in these square brackets. We write this first as it is, that is equal to n into n plus 1 by 6 into, by taking the LCM of these denominators, we get 2. Now in the numerator, we use here distributive property n square plus n plus 2n plus 1 plus 1. Okay. That is equal to n into n plus 1 by 6 into, in the square brackets, we are simplifying the terms. So n square plus n plus 2n, 1 plus 1 is equal to 2. So we have 2. The whole divided by 2. That is equal to n into n plus 1 by 6 into here, if it is nothing but a quadratic expression. We are writing the factors of this quadratic expression by splitting the middle term. Already middle term was splitted into two terms. So from these two terms, we are taking n common factor, then we get n into n plus 1 plus. From these last two terms, we are taking two common factor, then we get n plus 1. That is equal to n into n plus 1 by 6 into, again in the numerator, if you observe, n plus 1 is the common factor. By taking out this common factor, what will you get here? N plus 2 whole divided by 2. That is equal to, finally, we multiply n into n plus 1 into n plus 1, n plus 1 whole square into n plus 2 whole divided by 6 into 2, 12. This is the sum to n terms of the given series. We have found sum to n terms of the given series as a single term. This is a single term. Okay, my children. Likewise, we have to find the sum to n terms of a given series into a single term. Right. Now come to the next question. Question number 8. Find the sum to n terms of this series whose nth term is given by n into n plus 1 into n plus 4. In the previous questions, from question number 1 to 7, we have found nth term of the given series. But here, they have already given nth term of the given series. Already they have given. Simply, we have to find sum to n terms of this given series. So, half of the solution they have already given. This was already given. Simply, we have to apply sigma notation. Okay, my children. Right. Come to the solution part. An denotes nth term of the given series. That is equal to, what is nth term of the given series here? N into n plus 1 into n plus 4. Now, by multiplying these three terms, by multiplying these three algebraic expressions, finally we get n cube plus 5n square plus 4n. We got three terms, namely n cube plus 5n square plus 4n. For these three terms, we have to apply sigma notation to find the sum to n terms of the given series. Therefore, Sn is equal to sigma k is equal to 1 to n ak is equal to sigma k is equal to 1 to n k cube. In the place of n, we are writing k. Please remember this point, my children. That is plus 5 into sigma k is equal to 1 to n k square plus 4 into sigma k is equal to 1 to n k. You know already the values of these sigma notations. That is equal to sigma and k is equal to 1 to n k cube denotes sum of the cubes of the first n natural numbers. What is the value of this sigma notation? N square into n plus 1 whole square by 4. Plus, come to the second term, 5 into this sigma notation denotes sum of the squares of the first n natural numbers. What is the value? N into n plus 1 into 2n plus 1 by 6. Plus, come to the third term, 4 into this sigma notation denotes sum of the first n natural numbers. What is the value of sigma k is equal to 1 to n in k, n into n plus 1 by 2. So we have written the values of sigma notations in this step. After that, we have to simplify these three terms and make it as a single term. Okay, my children? Right. That is the remaining part of this question. That is equal to, if we observe these three terms, n into n plus 1 by 2 is a common factor. We have taken out. We have taken out that n into n plus 1 by 2. Then we get here from the first term, n into n plus 1 by 2. Plus from the second term, after taking out n into n plus 1 by 2, we get 5 into 2n plus 1 by 3. Plus from the third term, if we are taking n into n plus 1 by 2 as common factor, finally we get 4. Okay, my children? Right. in this square brackets, we simplify these three terms and we make it as a single term, right? That is equal to n into n plus 1 by 2 into, if you take the LCM of the denominators 2 comma 3, we get a 6. LCM of these two denominators is 6. Then we get here in the numerator 3n square plus 3n plus 20n plus 10n plus 24. Okay, my children, if you are strong, if you know how to add two fractions, how to simplify two fractions, then you can understand this numerator part. Okay, my children, right? That is equal to n into n plus 1 by 2 into, by simplifying these terms in the numerator, we get 3n square plus 23n plus 34 by 6. So we got finally n into n plus 1 into 3n square plus 23n plus 34 by 24. Here we cannot write the factors of this quadratic expression. That is why we have left. This is a single term. We have found sum to n terms of the given series as a single term. If it is possible to write the factors of this quadratic expression, we have to write the factors of the given this quadratic expression. Otherwise, we leave it as it is. Okay, my children. Right. Now, come to the next question, question number 9. Same procedure, my children, nothing else, nothing special. Okay. Series may vary from question to question. Questions may be different. Questions may be different, but procedure is same. Please remember the procedure. Remember the steps what we are following here. Okay. So come to the question number 9. Find the sum to n terms of this series whose nth term is given by n square plus 2 power n. This is the nth term of the given series. We have to find sum to n terms of the given series. Come to the solution. an denotes nth term of the given series, that is equal to n square plus 2 power n. So we have to find sum to n terms of the given series. It means we have to apply the sigma notation for this equation. Therefore, Sn is equal to, in the place of n we write k. Remember this point. So sigma k is equal to 1 to n k square plus 2 power k. Now we split these two terms and we write the sigma notation 2 times. Sigma k is equal to 1 to n k square plus sigma k is equal to 1 to n 2 power k. Let us consider this is equation 1. Now consider this second part, second term, that is sigma k is equal to 1 to n 2 power k, that is equal to 2 power 1. We are substituting k values 1, 2, 3, 4 and so on. Then we get these three terms, and so on. 2 power 1 plus 2 square plus 2 cube plus and so on. Understood? This is series, my dear children. By substituting the k values in this term, we get 2 power 1, 2 square, 2 cube, 2 power 4. Since it is a sigma notation, we are substituting plus symbol in between the terms. So the above series 2 comma 2 square comma 2 cube, it is a GP, geometric progression. With both the first term and common ratio is 2. Here first term is also 2 and the common ratio of the geometric progression is also 2. So we know that sum of the n terms of geometric progression, if we are r is the common ratio is greater than 1, yes, a into r to the power of n minus 1 by r minus 1. By using that formula, we are finding the value of this second term. So 2 into 2 power n minus 1 by 2 minus 1. So here in the denominator we get only 1. So we are not writing 1 in the denominator. And finally we get 2 into 2 power n minus 1. This is the value of this second term. Therefore, from 1 and 2, we obtain Sn is equal to sigma k is equal to 1 to n k square plus we have already found the value of a second term, 2 into 2 power n minus 1. That is equal to, if you observe the first term, it is nothing but sum of the squares of the first n natural numbers. What is the formula? What is the value of sigma k is equal to 1 to n k square? Yes, n into n plus 1 into 2n plus 1 by 6. Plus, we are writing this second term as it is. Here, it is not possible to write the sum to n terms of this given series as a single term because there is no common factor. That is why this is the required sum to n terms of the given series. Okay, my children. Right. Now come to the question number 10. Find the sum to n terms of the series whose nth term is given by 2n minus 1 whole square. This is the nth term of the given series. Here also we have to find sum to n terms of the given series. Now come to the solution part. An, that is equal to 2n minus 1 whole square. If you observe this expression, it is in the form of a minus b whole square, where a is equal to 2n and b is equal to 1. What is the formula? A minus b whole square formula. Do you remember? A square minus 2ab plus b square. By applying that algebraic identity, we get these three terms, 4n square minus 4n plus 1. Okay, we got nth term of the given series. Now we have to apply sigma notation. Therefore, Sn, to find the sum to n terms of this given series, we have to apply sigma notation to the nth term of the given series. That is equal to sigma k is equal to 1 to n, ak is equal to sigma k is equal to 1 to n, 4k square minus 4k plus 1. Previously also I told you, in the place of n, we write k. Then we get this expression. Now, for each and every term, we apply the sigma notation by using the distributive property. That is equal to 4 into sigma k is equal to 1 to n k square minus, for the second term, minus 4 into sigma k is equal to 1 to n k plus, for the last term, sigma k is equal to 1 to n 1. Okay, my children, that is equal to 4 into, if we observe the first term, this is sigma notation denotes just the sum of the squares of the first n natural number. What is the value of this sigma notation? Yes, n into n plus 1 into 2n plus 1 by 6 minus 4 into this sigma notation just to denote sum of the first n natural numbers. What is the value of this sigma notation? Yes, n into n plus 1 by 2 plus sigma n is equal to 1 to n 1. What is the value of this sigma notation? N. At the beginning of this exercise, I gave this formula. We have to memorize these formula well, my children. Without learning these formula, you cannot find sum to n terms of the given series. Okay, right. That is equal to, here 2 times 2 3 times. So finally we get 2n into n plus 1 into 2n plus 1 by 3 minus, here 2 1 times 2 2 times, and finally we get the second term as 2n into n plus 1, and we write the third term as it is plus n. Here the remaining part is we have to simplify these three terms to make it as a single term. If it is not possible, we leave it. As we have left for the 9th question, we leave that as it is. Otherwise, as far as possible, we have to convert these entire, all the terms into a single term. Okay, my children? Right. That is equal to, if you observe these three terms, n is a common factor. That is why we have taken out the common factor n. Then from the first term, what will you get? 2 into n plus 1 into 2n plus 1 by 3. So multiplying the two expressions, we get 2n square plus 3n plus 1 by 3 minus, after taking the common factor n outside, what is the second term? 2 into n plus 1 plus, after taking the n as common factor from the third term, we get here plus 1. Okay. that is equal to n into, by taking the LCM of the denominators of these three terms, that is 3. In the numerator, you know how to write the numerator part. It is nothing but addition of fractions. If you know addition of fractions well, then you can write the numerator easily. I have explained many times how to write numerator part when you are adding fractions or when you are subtracting fractions. So by using that knowledge, you get this numerator 4n square plus 6n plus 2 minus 6n minus 6 plus 3. Now we simplify these terms in the numerator. That is equal to n into, finally we get 4n square minus 1 by 3. Again, this can be written as, this is a quadratic expression in n. So we can write the factors of this quadratic expression as 2n plus 1 into 2n minus 1. So finally we get n into 2n plus 1 into 2n minus 1 by 3. So finally we have written the sum to n terms of the given series as a single term. Okay, my children? Right. Understood this presentation, my children? Understood this presentation? I will post this presentation as a PDF, and I will post this video also in the Google Classroom. If you want to watch the video, again watch the video carefully and completely, and write the classwork notes and submit your classwork notes. You cannot escape, you cannot skip in submitting your classwork notes, in doing your work. Yes, what, my dear Melam? What do you want? What do you want? He left the meeting. Yes, my dear children. Yes. Now the time is 3 past 11 minutes. 3 past 11 minutes. Let us revise the formula once. What is the nth term of an arithmetic progression? Tell me, any one of you, just to raise your hand and tell the answer. Remaining students will listen, they will learn. What is the nth term of an arithmetic progression? If any one of you come forward, raise your hand and tell me the answer. Yes, yes, Amma Mahima, tell me, what is the nth term of an arithmetic progression?
Sir, Sn is equal to a plus n minus 1 times d.
Yes, very good. Okay, my dear children, not Sn, Amma. Sn means sum. Capital letter S denotes sum. You should tell me Tn. T means term, nth term, Tn. Okay. Please
Okay.
rectify these mistakes. Okay. Tn is equal to not Sn. S denotes sum. T denotes term. Term, term. Okay. What is the sum of the first n terms? So what is the formula to find sum to n terms of an arithmetic progression? Sum of the first n terms. Sum of the first n terms of an arithmetic progression. What is the formula? You have already learnt in the earlier class. You are taking so much time. This is not a long answer type question. Yes, my dear Catherine, tell me.
Sir, Sn equal to n by 2 into 2a plus n minus 1d.
Very good, Amma Catherine. Sn is equal to n by 2 into 2a plus n minus 1 into d. And another formula is n by 2 into a plus l. A stands for first term and L stands for last term of the arithmetic progression. You can use any one of these two formulae to find sum of the first n terms of an arithmetic progression. Now come to the geometric progression. What is the nth term of an geometric progression? Nth term of a geometric progression. Tell me. Nth term of a geometric progression. Yes, Maria, tell me, Ria.
So an is equal to a into r to the power n minus 1.
Very good, Maria. Yeah, okay, my dear children. Are you listening the answers? Are you listening the questions and answers? If you don't know, at least learn the formulae, learn the answers, listen the answers carefully and learn the formulae, learn the concepts. Very good, Maria. What is the formula to find the first n terms of geometric progression? Any one of you? Sum of the first n terms of a geometric progression. Yes, ma'am, Ria, tell me.
Sir, if r is lesser than 1, Sn is equal to a into 1 minus r to the power n by 1 minus r. If r is greater than 1, Sn is equal to a into r to the power n minus 1 by r minus 1.
Very good, Maria. Okay, my dear children, are you listening these answers? Please listen the answers and learn the subjects, learn the concepts. Without knowing, you cannot solve the sums. Okay, my dear children. Right. Now the time is 3 past 16 minutes. Now you can leave the meeting, my dear children. Take rest. Take care of your health, my dear children. Stay at home. Stay safe. Sanitize your hands frequently and maintain social distance of 2 meters away from others and do your duty sincerely and seriously. Thank you all, my dear children. Thank you all. And learn the subject. Love your subject. If you love your subject, you can learn the subject. Okay, my dear children.
Thank you, sir.
Yes, thank you, my dear Nikhil. Thank you.